Good morning, students. We are going to start with the next topic, Can Matter Changes State, in the lesson Matter in Our Surroundings. Today, we are going to study the effect of change of temperature on solid state and the liquid state. In this first diagram that we see here, this activity is how the heating affects the solid state and changes it into the liquid state. For this experiment, what we need is a tripod stand, a Bunsen burner. Over the tripod stand, we place the wire gauge. Over wire gauge, we place a beaker containing ice. In the beaker containing ice, a glass stirrer, a stirrer rod, or simply the stirrer is placed. A thermometer, and this thermometer is the laboratory thermometer. A laboratory thermometer is hung into the beaker with the help of the clamp stand or the iron stand. Now, once the entire setup is done, we start heating the beaker on a low flame. We have to note the temperature when the ice starts melting. We also note the temperature when all the ice has converted into liquid water, and we record the observations for conversion of solid to the liquid state. We found that when we start heating ice, the temperature in the thermometer increases. A certain stage comes when the thermometer reading does not change, that is, the temperature becomes constant. In case of ice, the constant temperature is 0 degrees Celsius. We find that even when we are further heating ice, the beaker, the temperature in the thermometer does not change its reading. It becomes constant. We are going to find out what this is, why this is, and what happens when we start heating the solid state. Here in this particular experiment, we are referring to the example of ice. Right? We are going to talk about the next diagram later. This next diagram is a similar setup what we have done in the previous one, except for that when the ice converts into liquid water, water starts heating and changes into, after boiling, changes into vapors. So we'll come to this diagram later. Right? Now let's talk about what happens when we start heating a solid. When we start heating or increasing the temperature of the solids, the kinetic energy of the particles increases. And because the particles, they have more kinetic energy, so they start vibrating at their place with a greater speed. This energy supplied by the heat overcomes the force of attraction between the solid particles. The particles leave their fixed positions because now they can overcome the force of attraction between them, and now they start moving more freely. A stage is reached when the solid melts and is converted into the liquid. Remember, in solids, the particles are packed close to each other. They do not move they do not move leaving the place, rather they vibrate at their place. Whereas the liquids, the particles are a little away from each other. So when a solid melts, the distance between the particles increases and the phase becomes liquid. Now, this change of solid from liquid is called melting or fusion. So how do we define melting point? The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. The melting point of ice is 273.15 Kelvin or 0 degrees Celsius. We normally in the due course of teaching learning, we talk about Kelvin temperature. 0 degrees Celsius is not 273.15 Kelvin, but we round it off to 273 Kelvin, right? Then the state we have already discussed, melting and fusion. the change of solid state into liquid state is also called as fusion. So when we talk about fused solid, it is the solid which has melted. Now we come to the topic, the question that we just talked about earlier, and that is, when a solid melts, its temperature remains the same. So where does the heat energy go? That is, at 0 degrees Celsius, when we are still heating the beaker, right? Why doesn't the temperature in the thermometer show? The answer to this we find in the next paragraph. You must have observed during the experiment of melting that the temperature of the system does not change after the melting point is reached. That is, after 0 degrees Celsius is reached, the temperature does not change even if we continue to heat the beaker. This heat, let's explain what happens here. This heat, which is not showing in the thermometer, gets used up in changing the state from solid to liquid by overcoming the forces of attraction between the particles. And as this heat energy is absorbed by ice without showing any rise in the temperature in the thermometer, we say it is hidden in the contents of the beaker, and this hidden heat is called the latent heat. And because here the solid is converted into liquid, fusion is taking place, so we call it as latent heat of fusion of ice. So how do we define latent heat of fusion of ice? The amount of heat energy that is required to change 1 kilogram of solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. So particles of ice absorb the latent heat and changes into the liquid state, that is the water, right? So we say particles, another question here, particles in water at 0 degrees Celsius, that is the melting point. Particles in water at 0 degrees Celsius have more energy as compared to the particles in ice at the same temperature. I repeat, particles in water have more energy as compared to the particles of ice. I can say that in the other way also. Particles of ice at 0 degrees Celsius have less energy as compared to the particles of water. As a result, the ice particles at 0 degrees Celsius have more cooling than the water particles.